Okay, so now we'll move on to the next part of our lesson, sketching gradient functions. Okay, look. So they say we can use the features of a given function to sketch the corresponding gradient function. Gradient function means what? It means your dy by dx function. Okay, so they have given you a table here and they have told you how to look at the y graph, the fx graph, and how to draw the corresponding gradient graph. Okay, so let's see how it's done. Okay, so this is the table for the this is the y table and this is the gradient table. I mean, like basically how you can look at your fx graph and convert it to the respective gradient graph, like without doing any calculation. Okay, so you need to be able to draw the gradient graph without doing any calculation. Okay, so let's see how we can draw it without doing any extra work. Now they have told you, now at a maximum or a minimum point, what happens to the gradient? At the maximum or a minimum point, your gradient is 0, right? Your gradient is 0, isn't it? So that means your f dash x value becomes 0. Do you hear me? Your f dash x value becomes 0. So in this case, your graph is y equal f dash x. So when your f dash x becomes 0, it means y becomes 0. So when y becomes 0, it means in the gradient graph, it's the place where you cut the x-axis. Do you see this? In the grade, so you need to kind of remember this table. It will help you to do all these sums very easily. So at a maximum or a minimum point, the gradient, the f dash x becomes 0, isn't it? So that means you cut the x-axis. Okay, and then at a point of inflection, what happens? You know, at a point of inflection also gradient is 0. But however, you know, on either side of the graph, you have the same gradient, the positive. Either side, you have either positive gradient or you have negative gradient, isn't it? So then they say for that one, for a point of inflection, what happens? You touch the x-axis. Can you see? You touch the x-axis. Then the next one, positive gradient. So positive gradient means, you know, your f dash x is, if you have a positive gradient, what is your f dash x? Your f dash x is greater than 0, right? Do you remember? So that means your graph is above the x-axis. When you're above the x-axis, the y values are positive. Now remember, in this side, your y values represent whom? Look at this. In this side of the graph, the y values represent the f dash x values. Do you see? Basically, your f dash x is the y-axis here. Okay, so that means the gradient values are sketched for the y values. Okay, so whenever you have a positive gradient, your f dash x, the gradient graph is above the x-axis. And when you have a negative gradient, you know f dash x is less than 0. So when your f dash x is less than 0, your gradient graph will be below the x-axis. And then they have given you some clues here. Vertical asymptotes are going to be vertical asymptotes. They won't change. Vertical asymptotes are vertical asymptotes. And then horizontal asymptotes, what do they say? A horizontal asymptote becomes what? A horizontal asymptote at the x-axis. Now, you know, horizontal asymptote means it's a flat line, right? X equals, not x equal. Horizontal asymptotes are like you have y equal 3, something like that. This is a horizontal asymptote, right? So they say when you make it to the gradient f dash x graph, the horizontal asymptote converts to what? The horizontal asymptote there at the x-axis. So you need to remember these conversions. And if you have a vertical asymptote, does it change? The vertical asymptote, wherever it is, it will not change. So I think the best way to use this is, let's go to the sum and let's apply these rules into a sum. Okay, so let's go to the next exercise and let's try the sums. Okay, let's go to exercise 7C. So I have brought the table here so that we can refer it and draw the graph. Okay. For each graph given, sketch the graph of the corresponding gradient function on a separate set of axes. Show the coordinates of any point where the curve cuts or meets the x-axis and give the equations of any asymptotes. Okay. Shall we start on this? Okay. So what I'll do is, first I have my original fx graph. The fx graph is given to you. What do we need to do? We have to convert our fx graph to the f dash x graph. Okay. So basically I'm trying to draw the graph of f dash x against fx. Okay. F dash x against x. Okay. So what I'll do is this. What are the main things we need to consider? Any maximum or minimum points are definitely needed, right? So you see I have two maximum points here. So what are the maximum point x values? I only need the x values. Remember, I'm drawing my graph against x. Okay. So I need the x values. What is the maximum point x value? It's -9, right? The maximum point x value is -9, right? Are you all with me? This point is -9. And then The other maximum point x value is 6, right? And the minimum point, you can see we also have a minimum point. At the minimum point, x value is 0. Are you all with me? So then we learned here at a maximum or minimum point, what happens in the gradient graph? Your graph will simply cut the x-axis. It simply cuts the x-axis. Okay, so what are the cutting points of the x-axis in the f dash x graph then? The cutting point starts where at -9. So you can mark -9. The other cutting point is at x is 0. So these are all coordinates. -9 is a cutting point, 0 is a cutting point, the other one is 6. 6 is a cutting point. So these are the three places where the f dash x graph cuts the x-axis. Okay? Is that okay? So use this rule. The maximum or minimum points are the places where you cut the x-axis. Okay, next thing that we need to do is, okay, do we have a point of inflection? No. Okay, let's go for the positive gradient. From where to where do I have positive gradient? So let me mark the positive gradients here. So you can see here, I think this section of the graph, we have positive gradient. Do you agree with me? Behind -9, we have a positive gradient. Agreed? And then from -9 to 0, what kind of gradient do we have? There is a negative gradient. Are you all with me? Okay, so look at the gradients. You know, when your graph is moving upwards, if fx is increasing, the gradient is positive. If your fx is decreasing, gradient is negative. Are you with me? And then the next one again, next part of the graph, I think you can see when you're turning and going up here, it's what? Gradient is positive or negative. When you're moving up, gradient is positive. Do you agree? The next part, after 6, again, you can see the graph is falling down, which means the gradient is negative. Are you all with me? So now all you need to do is to apply these rules into this table. Look, this table says if you have a positive gradient, what does it say about the graph? The graph should be, look, when you're having a positive gradient, your graph is above the x-axis. When you're having a positive gradient, your graph is above the x-axis. So you can see the green color parts I marked are the parts that are having positive gradients, which means those parts must be above the x-axis. The blue color parts are the ones that I have marked, the ones with the negative gradient. They must be below the x-axis. Are you all with me? So then let me draw the graph. So that means before -9. Before -9, when I go to cut this, now you know at -9 we cut, the gradient graph is crossing the x-axis, right? So before -9, behind -9 at this place, where is the graph? Above or below? The graph is above, which means it comes from up. Are you with me? This graph comes from up here and goes down. Okay, so the graph comes from up here and goes down. And then what happens? From -9 to 0, what happens? You have a negative gradient. If you have a negative gradient, what happens? Your graph is below the x-axis. Below the x-axis, and now are we just going to draw it like this, like forever below the x-axis? No, you know you need to again meet the x-axis at 0. Can you see these points are marked? So you have to draw it in such a way. Okay, we need to meet this point 0 also again. So that means it needs to make a turn and come here, right? Because now anyway, -9 to 0, it's below the x-axis means it's a negative gradient. Are you all with me? Then after 0 to 6, from 0 to 6, what happens? You can see again I have a green color, the green color part, which is positive gradient, which means what? The graph is going down or up. Positive gradient means you are above the x-axis. So in that case also, should I draw just up like this? No, you know you need to meet the graph again at 6, right? So that means you need to make a turn again. Make a turn again. Are you with me? From 0 to 6, you have positive gradient, so it's above the x-axis. Then after 6, what happens? You can see after 6, you have the blue color part of the graph, which means what gradient? Negative gradient. Negative gradient means what? Your graph is below the x-axis, which means should I turn this and go up, or should I just continue down? Continue down. I need to continue down. So this is the gradient graph. And are there any negative vertical or horizontal asymptotes? No, so I don't need to be bothered with that. So basically, this is my gradient graph. Okay. Ask me, let me know if you have any doubts. So when you're drawing these graphs, one thing is these peaks, you could make it a little bit lower, you could make it a little bit higher. That's entirely up to you. And you are not, you don't need to find the turning points. Okay, you don't need to find the turning points. I mean, basically what they need to see in the gradient graph is every place where you cut the x-axis. Okay, every place where you cut x-axis is what you need to show, and the shape, whether it's above or below the x-axis, is what they need to see. Okay, let's try part B also. Let's draw the gradient function. Okay, part B. Look at the part B graph. So in here we can see there are, first take the most distinctive features. Okay, do we have a maximum or minimum point? First of all, there are no maximum or minimum points. You can clearly see. We can see we have a what asymptote here? Y equal 10 is a horizontal asymptote. So what is the rule that they have told us? Whenever there is a horizontal asymptote in the fx graph, what happens? The horizontal asymptote comes to the x-axis, which means y equals 0 asymptote becomes what? Y equals 0, or y equals 10 asymptote becomes y equals 0 asymptote. Sorry. So basically you get here something like this, right? So y equals 10, because they tell you here the horizontal asymptote, any horizontal asymptote will become an asymptote, horizontal asymptote at the x-axis. So at the x-axis means this asymptote comes on top of this line. Do you hear me? So this is the y equals 0 line. Okay, the asymptote, because you have to follow this table. Horizontal asymptote becomes a horizontal asymptote at the x-axis. Okay, then what's the next thing that we can do? Now, there are no vertical asymptotes, and there are no minimum maximum point. There are no points of inflection. So now, so in that case, your gradient should follow one pattern, right? Either it should be completely positive gradient or completely negative gradient, because there are no turning points. If there is a turning point only, you get a sign change in the gradient, isn't it? A turning point will give you a change in the gradient sign, plus minus. But when there are no turning points, then it should be like one sign for the gradient. So what do you have here? This is the what gradient? I think you can see we have a positive gradient. Then look at the steepness. Is it getting more steeper or less steeper? Look at the gradient. It gets less steeper, right? So that means your gradient value is falling. And then when it becomes, you can see when it comes closer to this asymptote y equal 10, it becomes what? It becomes closer to becoming a flat line, right? A flat line means what? The gradient becomes almost close to 0, right? Because whenever you get a flat line parallel to x-axis, it means it's parallel. It means the gradient is 0. So which means what? You can understand your gradient is highest for the negative x values. And then when you come closer to the positive x value, do you see that your gradient value is falling, coming closer to 0? Can you see here? Because the slope is higher here, your gradient is higher. Gradient is a high value. And when you come up, what happens? Eventually, when you come up, do you see the gradient value is gradually decreasing? Gradient is decreasing, right? Do you see gradient gradually decreases? Can you see? Gradient gradually decreases until what? It comes almost close to 0, because you get close to a asymptote. That means it becomes parallel to x-axis. Do you get what I'm saying? So how do we draw this now? How do we draw it here? So you can see for the negative x values, do you understand that the gradient, the f dash x values is it low or high? At the negative x values, the f dash x values should be quite high. And then when you come close and closer to the positive side, positive x, the gradient value is decreasing and becomes almost close to 0. So which means what? You need to draw a line that looks like this. The gradient is decreasing, right? The f dash x values are high when x is negative, and the gradient is decreasing. It's decreasing and becomes almost close to 0 at this point, the gradient. Can you see? So this is the gradient graph. Basically try, and then because it's a positive gradient, the entire thing is above the x-axis. It's a positive gradient, so it should be completely above the x-axis. Okay, so this is the second one. Try the third one also. Okay, now in part C, the first thing I can see is there are two sections of the graph, and I think we can see a vertical asymptote. Can you see vertical asymptote x equal -7? So for vertical asymptote, what have they said for the gradient graph? Does it change? Vertical asymptote is the same vertical asymptote. It doesn't change. Does it go to the y-axis? No. So basically when you draw the graph, first things first, Mark the vertical asymptote. Vertical asymptote is at x equal minus 1 and that will not change. That does not change. Do you get me? Okay, x equal minus 7. Okay, so now what we'll do is let's take a look at the major points. Okay, now remember basically these are the main things you need to know. Positive gradient is above x-axis, negative gradient is below x-axis. Now here in this part of the graph, do I have any turning points? No, so then definitely I have to sketch the graph just by looking at the gradient. Now look, when you are looking here, is your graph the y values? Do you see it's decreasing? So which means what? This is a what gradient? It's a negative gradient, and I think you can see the negative gradient slope is increasing. Can you see it's a negative gradient? Okay, it's a negative gradient. So then basically the negative gradient starts from here. So then at the beginning, do you see the gradient values are lower? Kind of lower, and then when you go down, because it gets more steeper, the gradient gets higher, right? Do you hear me? Starting values are like maybe a little bit low, like if you think of it like this, like over here, it's even lower, right? Can you see? So here the values are low, negative, but close to 0. And then when you go over here, it becomes like higher and higher. Are you with me? So because of that, for the x negative side, do you see before minus 7? Before minus 7, in this side, do I go up or down, by the way? Down. I go down. And do I start close to 0 or do I start like from down here, or should I start up over here? Looking at this. Do you see the gradient values are like starting from like the flat line? So it's close to 0. The gradient value is starting from close to 0. And then you go down, right? Kind of something like this, because the gradient values get higher and higher. And this is an asymptote, right? Are you all with me? Let's go to the other part. I think we can see here 4,3 is a special point. Why? 4,3 is what? Minimum, maximum, or point of inflection. I think you can see before the point also we have a negative gradient, and after the point also we have negative gradient. It's a point of inflection. So what happens at a point of inflection? They say you touch the x-axis. What's the point of inflection? X value is? The x value is 4, right? So go and mark the x value 4. At x value 4, you should touch the x-axis. You understand the meaning of cutting x-axis and touching? Cutting means you cut and go down. Touching means you don't touch, cut and go down. You touch and you make a turn and go up again. Or you come from down, touch and go down again. Like you don't cut. The difference between cutting and touching. Do you hear me? Cutting means at this point this cuts and go. Touching means at this point you come, you touch and you go down. Or it can be even from the other way. You come up and you touch and you go up. Could be either way. Okay, now you need to decide which of these graphs are correct. Okay, so I have my touching point here. Now what happens here? Is the gradient positive or negative? These gradients, are they positive or negative? They are negative. They are negative. And afterwards also, after the point of inflection also, it's negative. So do you see how the touching part works? Can you see how the touching part works? So you can see that these gradients are quite large, right? This is very steep gradient, which means am I starting from close to 0 or should I start from down? Down, because these values are larger. Okay. So then I start from down and then I go up to 4, make a touch and come down. Because again, at this point, the gradient is 0 and then again it gets the gradient values get larger. Do you see? Okay, so this is the f dash x graph against the x values. Try the part D. Okay, let's go to question number D. So, okay, again, we have several important points here. Number 1, we can see we have a minimum point, and there's a maximum point. Minimum point at x equal minus 2, maximum point, I only need the x value. You can see here, we are not bothered with the y values. Okay, you only need the x values and we are bothered with the gradient. Okay, so then what happens here? In part D, so when I draw the gradient graph, okay, so what happens? The main points are minus 2. So at minus 2, we have a place where the graph cuts the x-axis because it's a minimum point. Again, where is the next cutting point? At maximum point as x equals 0, 6. So x equals 0. So you know when there is a maximum or minimum, it's again what? It's a place where you cut. It's a place where you cut. So the next cutting point is at x equals 0. So this is again a point where we cut the x-axis. Okay. And then do I have any other turning points? No, but I do have a what asymptote? I have a horizontal asymptote. Do you see y equals 3 is a horizontal asymptote? A horizontal asymptote becomes what? A horizontal asymptote at the x-axis. So basically, you have a horizontal asymptote at the x-axis. So remember, this asymptote is required to show this part right now. The asymptote is required to show that at this part of the graph, it becomes flat here. So this asymptote y equals 3 is only relevant for this part. Okay. So then even for when you're drawing the gradient also, you need to remember that the gradient is, this asymptote is relevant for the last part. Okay. Now let's take the gradients. So what do you see here? I think this part I'll mark in blue. You can see the y values are decreasing. Y values are decreasing means it's a what gradient? A negative gradient. Negative gradient means what happens? It is below the x-axis, and you should realize when you come from up to down like this, the gradient values is decreasing or increasing when you come towards the turning point. Whenever you come towards the turning point, the gradient will decrease. At the turning point, gradient is 0. Do you get it? So when you're up over here, you have a very high gradient. When you come down, eventually gradient value is it's losing in value, and when you come to the turning point, it reaches 0. And remember, it's negative. So that means, how do you draw this particular graph? How do you draw this particular graph? I have to start from down, and I have to start from a negative side. I have to start from down below in the negative side. Do you see what I'm talking about? You start from down below in the negative side. Okay, and then when you come over here, the gradient comes closer and closer to 0. At -2, gradient becomes 0. And then what happens? From -2 to 6, what happens? The green color part of the graph, you can see the gradient, the y values are increasing, which means what? The y values are increasing means your gradient is positive. Positive means the graph is above the x-axis. So it needs to again go like this and cut again at 0. So then how do you make it happen? We can't just continue to go up like this. I have to make a turn here, right? I have to go up and make a turn here. The reason I'm making a turn is because I need to meet the x-axis again at 0. So we cut and go at -2, and then when we are above the x-axis, the f dash x is positive means that you're having a positive gradient. Then again, what happens after this point? I think you can see again, we come to the part where we have what gradient? At this point, this gradient is negative. Negative gradient means a negative gradient, and what do you notice? So we start with the 0 gradient. And I think you can understand what happens, because it's a turning point, the gradient starts at 0. And what happens? The gradient is increasing. Look, the gradient is increasing. At this point, the gradient is 0. And then you start with the gradient values that are closer to 0. And you see the gradient increases, and then again it decreases because it kind of becomes a flat line. Can you see the gradient is starting at 0 here? It starts at 0 here, and then you get the negative gradient value increases, and then do you see again the line becomes flat? When the line becomes close to becoming a flat line, the gradient becomes 0 again, right? So which means what? How does it affect this graph? You go down, but do you continue to go down? No, you can see that the gradient is again becoming flat, means the gradient becomes 0 again. So the gradient value increases a little bit, and then again what? And then again what? Can you guess? It makes a turn again and makes the asymptote here. Do you see? Something like this. It makes an asymptote here because you again reach the gradient 0 here. You go to a negative gradient, it increases a little bit, but then it again, because it reaches the 0 gradient at this point, it reaches to almost 0 gradient. You need to bring it back up again and show that gradient is reaching close to 0, because f dash x equals 0 is here. So that means when you are closer to the axis, it means your gradient is 0. Do you understand? Try part E. Now look at part E. In part E, what happens? Look, in part E, you can see there are no turning points. So there are no places where you cut the x-axis. There are no turning points. I think you can see this line is a horizontal asymptote. We can kind of see it. So horizontal asymptote is at the x-axis. So this is basically the same thing. Okay, so part E. The horizontal asymptote is at the same. The vertical asymptote doesn't change. X equals 6 is a vertical asymptote. So that will not change. So first you mark the vertical asymptote x equals 6. Okay, this is x equals 6. Now look. First thing is decide whether you have a positive gradient or negative gradient, because that tells you whether your graph is above or below the x-axis. Are you with me? Now looking at this section, what do you understand? The y values are increasing or decreasing? They are increasing. That means it's a what gradient? That means it's a positive gradient, which means this graph is increasing. It's a positive gradient. That means when you are drawing behind x equals 6, your gradient values, your f dash x values, you need to draw it where? Above or below? Below. So you have to draw above the graph. It's a positive gradient. Okay, so the whole thing should be above the graph because it's a positive gradient. Now, the other thing you need to realize is, okay, you understand that your graph should be drawn in this section. Are you with me? Your graph should be drawn in this section. The other thing now is, look at this. You start for the negative x values at the very negative x side. Okay, check the negative x side. Do you have a gradient? Do you have a very large positive gradient or a very small positive gradient? Look, because it's almost close to a flat line, you really have a small positive gradient. And what happens when you move up the line? Do you see the gradient? And when you move like this up, when it comes close to being parallel to y-axis, you get a really large gradient. Okay, so basically what happens here, you need to understand that this one actually will kind of look the same. Ne? This line, you start for x, large negative x values, you get a negative, you get a positive small gradient, and then the gradient values will increase. Something like this. It looks almost similar to the shape of the graph. Because the gradient value starts at 0, start close to 0 and it becomes large when you come to close to x equals 6. Isn't it? And then the next one, what about the other side? Look at the other side, Pooja. What happens here? First of all, is it positive gradient or negative gradient? It is positive gradient. Now look, in this positive gradient, let's start with the x values close to 6. Start with the x values close to 6. Do you have a large positive gradient or large? Now you identify this is positive. Is this gradient when you are close to 6, is it large positive or is it small? Is it really close to 0? Do you see that when this is very steep? You are almost parallel to y-axis. Whenever you are almost parallel to y-axis, it's a large gradient. So which means after 6, after the asymptote, should I draw my gradient value close to this or should I start from the top? Now you can see it's a very large gradient. And it's a large positive gradient, which means you need to start from the top. You have to start from the top. And what happens? The gradient, is it increasing or decreasing? Do you see when you're getting closer to the x-axis, when you start getting parallel to x-axis, the gradient becomes close to 0. That's what happens, right? So when you're almost parallel to y-axis, you have a very large gradient. When you're getting parallel to x-axis, your gradient becomes close to 0. Understood? So then you have a very large positive gradient, which becomes to a very small positive gradient when your x values increases. So basically, you need to draw it like this. Drops in value. Do you see? This is how the graph works. Let's try part F also. Let's try part F. Let's see. In this one, you can see, do we have any special points? Do we have a maximum point, minimum point, or point of inflection? No. They have a, this is not a point of inflection like this one. Okay, wait, let me check. Y equals 4, y equals minus 4 are definitely what? Asymptotes. What asymptotes are they? They are horizontal asymptotes, right? So horizontal asymptote means it doesn't matter wherever it is, all the asymptotes come to where? X-axis. Okay, all the asymptotes come to the x-axis. Okay. So both the asymptotes come to the x-axis, okay? Because where y equals 4, y equals minus 4 will both become y equals 0 because the horizontal asymptote becomes what? A horizontal asymptote at the x-axis. Okay, then what happens here? I think you can see over here. Over here, look. What happens to the gradient? You start with a very low gradient. Can you see? And by the way, is it positive or negative gradient? Can you see its y values are decreasing? It's a negative gradient, right? Now look, is your gradient increasing in value or decreasing? It is decreasing, right? Do you see it's decreasing? It's not decreasing, it's increasing. Can you see it's increasing the gradient? The steep. Okay, so what happens here? Now you can see you start with, the line is quite flat when you start near the asymptote, right? And then what happens? That means your gradient is close to zero. And it's a, since you identify the values are decreasing, it's a negative gradient, isn't it? It's a negative gradient. And then you can see the negative gradient starts where? Close to zero, right? At the negative x values, you start close to zero. Gradient starts close to zero. And what happens when you come down like this? Is your gradient value increasing in negativity or is it decreasing? Can you see it becomes more steeper, right? It becomes more and more steeper. Do you see it? It gets more steeper. Like I told you, when you are getting parallel to the y-axis, it becomes more steeper. So which means what? You start from here, where at the negative x values, we start with the negative gradient. Like you start from here, right? Look at what I'm pointing. Do we start from up here? No, because it's negative gradient. You can't start from up here. You have to start from down. Negative x values, you start from down because gradient is negative, close to zero, however. So you come like this and the gradient value is increasing. The gradient value is increased, and then what happens? At this point, this is not a point of inflection, because at a point of inflection, what needs to happen is the graph should level. At a point of inflection, if it's a point of inflection, it needs to come the other way, like this. It levels and goes like this. Because then here, can you see the gradient is decreasing? And then reaches zero and then again increases. But do you see that this is not a point of inflection? Because you start with the zero close to zero and then it increases. Increases to a certain point, and then what happens? Still, I think you can see it's still negative, right? Even this part of the graph, you're still going down. It's still negative. And what happens now? Afterwards, do you see the line becomes again flat again? Which means what? You increase in negativity. And what happens? I think you can see the biggest gradient you get at x equals 0 here. The largest gradient, because at this point you get the steepest slope. And then again it starts getting lower. And when you come to positive x values, you again reach the almost gradient 0 place. So here, this is the place where you have the steepest gradient. Do you get me? Steepest gradient means what? This is the place where you have the highest f dash value. See, this is close to 0, negative and close to 0. It increases. The slope is increasing, and this is the place where you have the biggest slope. Because afterwards, you see, it's again starting to flat out again from this point. So at x equals 0, you come to the highest gradient. The highest gradient where you have the negative gradient. And then after 0, it again flats out. Like this. It again flats out. Because and you need to make it go close to 0 because your graph is becoming flat, which means the gradient becomes close to 0. So that means it needs to be flat and it needs to come, the f dash x needs to come close to 0 again. Okay. So I hope this is clear. This was a little bit of a challenging part. You just need to realize the closer you are to the line, the parallelities to x-axis, your gradient is close to 0. The more close it is to the parallel to y-axis, the bigger the gradient. Okay, and then you just have to decide whether it's positive or negative based on whether the y values are increasing and decreasing. Okay, so this is the end of that part. We just have one more part to cover and this lesson is done. Okay.